All right. So next on the docket, we're going to start talking about two different forms of a linear equation, in particular the point-slope form and what we call the slope-intercept form. Each of those are useful. They tell us different pieces of information. You can probably tell by the names, they both have to do with the slope, which we talked about in the last video. The different forms than the forms we've seen, we sort of talked a little bit about in the past, different forms of linear equations. Not to sound like I'm making it up as I'm going along. All the other forms sort of work for their own different cases. So this is dealing with a linear equation in two variables, so x's and y's. It's a different form than what we were using in 8.1 with the systems. That was sort of an ax plus by equals c. That is a legitimate form, and in theory, any of the equations in this section could be written that way. But the two forms we're really going to be sort of using and having as our go-to are the point slope and what we call the slope-intercept form. So let's start with point slope. The idea here, probably not too surprisingly, is that if you have a line and you know the slope and you know any point that the line goes through, so any generic point x1, y1, right? So this is specifically, oh my gosh, let me see if I can have my hand look any bigger. Specifically, right, some values here, x1, y1. So this is some coordinates, right? This could be, -2, 5. This could be +3, 0, right? So any coordinate, any xy coordinate that the line goes through, and it has this particular slope, what we can do is get the point slope form of the equation, and what it's going to look like is this. So it's going to look like y minus y1 equals m times the quantity x minus x1. I've tried to color code this a little bit. I'm not sure how well it's sort of showing up in this video, but the sort of y1 value is green, the x1 value is purple. That kind of matches the coloring that we were doing when we were calculating our slopes in the last video, right? So the x1 and the y1 values here will be numbers. Those will be coming from the coordinates. And then the m value, right, is the slope. So either something that we've sort of calculated like we did in the last video, or something that we're just sort of given. If we're given what the slope is, then we can sort of use that directly. So as an example, right, let's find the point slope form of a line where the line has the slope -2, and it goes through the point 4, -1. So just a quick labeling exercise first, right? The idea is the m value, of course, is -1/2 is our slope. And then the sort of x1 and the y1 values would be respectively 4 and -1, right? So 4 is the x1 value and -1 is the y1 value. In the equation, so this is still an equation, so we're distinguishing a little bit between, right, y the variable versus the y1 value, which will be a number that's coming from the coordinate. So this is still an equation. This is not the kind of thing where we're just sort of plugging in these numbers and we're going to get one final number as like a quote-unquote answer, right? What we're getting here is just an equation for the line. So it's still going to have an x and a y variable. We're just using some of these x and y coordinates in the slope to get there. So all we're going to do is essentially sub these values in, right? So y is the variable y minus the y1 coordinate, right? The y1 coordinate is -1, so we're going to do minus -1. If you're thinking ahead, that's probably going to be, right, -1 is +1. And then on the other side, you've got -1/2 is your slope times the quantity x minus 4, right? So the x1 value is +4, so you can just set up x minus 4, and then you're good to go. So the final version here, if we just get rid of these double negatives, right, if I subtract a negative, it's really just addition. So y minus -1 is the same thing here as y plus 1. On the left equals -1/2 times the quantity x minus 4. And that's it. That's just the form of the equation. It's pretty fast, honestly, right? It really is just a matter of subbing these numbers in and then just getting rid of any double negatives and turning them into positives. Honestly, that's all we need to do. This is, in theory, a very straightforward thing to do. It's really just subbing numbers into the formula and just cleaning it up a little bit sort of as needed. So that's pretty good news. It's the biggest thing I see students do more than anything else is not really have any issues coming up with this equation, but because it is so fast, usually what people want to do is go further. You don't need to. This is the point slope form of the equation. So if that's what you're asking for, if that's what the homework or a test or a quiz is asking for, that's what you're going to write. Now, you can take that version and you can solve it for y. That's going to be, I think, in some sense, what your intuition tells you to do. I think if you have an equation, what you're going to want is it to be sort of y equals or x equals something. And what that's going to give us is it's going to give us the slope-intercept form. So that's the other sort of common form for a linear equation, slope-intercept. So rather than being, so point slope, right, is based on a point and the slope. Slope-intercept is based on the slope, which is still m, and then the y-intercept. The form here, the generic form, is here, y equals mx plus b. So there's no parentheses here. It really is just a pretty quick rearranging of whatever we end up here. It's just a rearranged point slope. Honestly, it's just taking that and solving for y. The algebra steps are going to be essentially the same every time. And what it gives you, right, m is still the slope. This b value is the y-intercept. That's where the line crosses the y-axis. And so the coordinates for that point would be 0, comma b. Whatever the b value is, positive or negative, that's where we're crossing the y-axis, and then the x value is 0. So if I take, in this case, let's sort of use the one that we had here, right? Y plus 1 is negative 1/2 times the quantity x minus 4. So if I try to rewrite this in slope-intercept form, all I'm doing is I'm essentially going to distribute on the right, negative 1/2, whoops, hold on, negative 1/2 times both of those values, right? If I'm going to distribute, so that would be negative 1/2 times x is negative 1/2 x. Negative 1/2 times a negative 4, right? 1/2 times 4 is 2, and negative times a negative would be a positive. So the right-hand side of this equation becomes negative 1/2 x plus 2, right? So I would say y plus 1 is equal to negative 1/2 x plus 2. To get this solved for y, all I need to do is just subtract the y from both sides. So minus 1, and I'll end up with this sort of final version, this this slope-intercept version. So solve for y equals negative 1/2 x plus 1. You're not writing it with any parentheses, right? This is just without any parentheses, and you can see here the slope is negative 1/2, the same as the slope that we started with, right, way up here. That hasn't changed at all, so that's a good sign. And then we shifted from this sort of random coordinate, 4, comma negative 1. We sort of shifted through some things, and we ended up with this b value, positive 1. So that means the y-intercept here would be 0, comma 1, 0, positive 1. Would just sort of be 1 up from the 0, 0 at the origin, the sort of center point. We're going to do another video with a couple more examples, but this is our basic process to sort of rewrite these equations in both of these forms. So point slope and slope intercept. Both are useful. We're going to sort of use them for different things. In particular, the slope intercept is really good for graphing, so that'll be kind of our basis for making any graphs. But that's still a couple videos away, so stay tuned.